Good morning all. So today we'll continue the problems on partial differentiation. In last two videos we have studied 6 problems. So today we'll study the 7th one, and in today's video we are going to study the approximate calculation of the values of the function by using the concept of differential. So here we have the first problem. You are asked to find out the approximate value of this expression 3.82 bracket square plus 2 into 2.1 bracket cube whole bracket raised to 1 by 5 by using the concept of differential or total differential, as we can say. Here we in order to find out the value of this function, approximate value of this function, let us consider we have the function in the form f is equal to or f xy is equal to x square plus 2y cube bracket raised to 1 by 5, where x is equal to 4 and y is equal to 2. So let us consider the function of the form fxy equal to 2x cube plus x square plus 2y cube bracket is to 1 by 5, and where x is equal to 4 and y is equal to 2. So if we consider x is equal to 4 and y is equal to 2, we can find out the value of fxy by substituting the value of x is equal to 4 here. It becomes 16, and substituting the value of y equal to 2 here, 2 cube is 8, 8 into 2 is 16 raised to 1 by 5. So this works out to be equal to 16 plus 16 32, 32 raised to 1 by 5 is 2. So the value of the function fxy works out to be equal to 2. Now if we consider these values of x and y, but in the given function the values of x and y are found to be slightly different than the one which we have assumed. So here we can find out the values of delta x and delta y. The value of x plus delta x is equal to 3.82 and the value of y plus delta y is equal to 2.1. So that we can obtain the values of delta x and delta y. So delta x will be equal to 3.82 minus x, x is 4, and delta y will be equal to 2.1 minus y is 2. Therefore, delta x works out to be equal to minus 0.18 and delta y works out to be equal to plus 0.1. So these are the values of delta x and delta y. Now we are given this function f of function of the two variables x and y expressed in the form x square plus 2y cube raised to 1 by 5. So we can obtain the expression for df, the total differential of this function, and the total differential of this function. So the values of delta x and delta y we shall write on this side. Delta x is equal to minus 0.18 and delta y is equal to 0.1. So let us remove this part. So we can write the total differential of this function f. Df will be equal to dou f by dou x dx plus dou f by dou y dy. So this is the total differential for the given function of two variables x and y. So here we are given the function f is equal to x square plus 2y cube raised to 1 by 5. So we can obtain the expressions for dou f by dou x and dou f by dou y. So let us obtain first the partial differential of f with respect to x. So this is dou by dou x of this bracket. The differentiation will be 1 by 5 into bracket x square plus 2y cube bracket raised to 1 by 5 minus 1 will be minus 4 by 5 into the differentiation of this bracket with respect to x is twice x. So these two, So this is equal to dou f by dou x is this expression. Similarly, we can obtain the expression for dou f by dou y. So dou f by dou y will be equal to what? Again differentiate f partially with respect to y. So once again it is 1 by 5 into bracket x square plus 2y cube bracket raised to minus 4 by 5 into differentiation of this bracket with respect to y. So differentiation with respect to y, where we want to differentiate, the differentiation of x square will be 0 and the differentiation of 2y cube with respect to y will be 6y square. This is 6y square. So use these expressions of dou f by dou x and dou f by dou y here so that we get the expression for df to be equal to. So this is 1 by 5 x square plus 2y cube bracket raised to minus 4 by 5 into 2x plus dou f by dou y is 1 by 5 into bracket x square plus 2y cube bracket raised to minus 4 by 5 into 6y square. Dx and dy will be there. Here there will be dx, 2x dx plus and dy there. So this is the expression for df. Now substitute the value of x is equal to 4 and y is equal to 2 and dx delta x can be approximated to dx and delta y can be approximated to dy. So we are using the value of delta x equal to minus 0.18 and the value of delta y dy as 0.1. In this expression we get 1 by 5 into bracket x is 4, so x square is 16 plus y is 2, so 2 cube is 8 into 2 is once again 16 raised to minus 4 by 5 into x is 4, so 4 into 2 is 8 multiplied by dx is minus 0.18 plus 1 by 5 into bracket 16 plus 16 raised to minus 4 by 5 into y is 2, its a square will be 4, 4 into 6 is 24 multiplied by dy is 0.1. So this is nothing but equal to 16 plus 16 is 35, 35 is 2 raised to 4, 2 raised to 5, 32 is 2 raised to 5. So this is equal to, so if we evaluate the value of this factor, 32 is 2 raised to 4, 2 raised to 5, and 2 raised to minus 1, 2 raised to minus 4. So it works out to be 2 raised to 1 by 6, 2 raised to 4. So this is 1 by 5 into bracket 2 raised to 5 raised to minus 4 by 5 into 8 into point minus 0.18 plus 1 by 5 into 2 raised to 5 bracket raised to minus 4 by 5 into 24 into 0.1. So this is the pi and this pi will get cancelled. So 2 raised to minus 4, 2 raised to minus 4 is 16, 2 raised to 4 is 16, so it is, since it is minus 4, it will be the denominator. So this is equal to 1 by 5 into 1 by 16 into 8 into minus 0.18 plus 1 by 5 into 1 by 16 into 24 into 0.1. So this works out to be equal to, if we evaluate this factor, it works out to be minus 0.018, minus 0.018, and if we evaluate this factor, it works out to be equal to 0.03. So this is equal to, so df works out to be equal to 0.012. So df works out to be equal to 0.012. So we have obtained the value of f and we have obtained the value of df. Therefore, f plus df, which is nothing but the given expression, so we can obtain the value of f plus delta f like this. Therefore, f plus delta f, which is nothing but the given expression 3.82 bracket square plus 2 into 2.1 bracket cube whole raised to 1 by 5 is nothing but equal to f is 2 and delta f is 0.012. So the value of this function works out to be equal to 2.012. So this is the approximate value of the given function. That is the approximate value of 3.82 bracket square plus 2 into 2.1 cube raised to 1 by 5. The approximate value of this function works out to be equal to 2.012. So that is how we can make use of the concept of this partial differentials in order to find out the approximate value of a certain function. So that is the 7th problem. Then we'll see the next one. Next problem is find the percentage error in area of ellipse when error of 1% is made in measuring major and minor axis. So we are given that the error introduced in the measurement of major and minor axis is 1% each, and if it is so, then you are asked to find out the percentage error introduced in the determination of the area of an ellipse. So we know the expression for the equation of an ellipse given by x square upon a square plus y square upon b square is equal to 1. So this is the equation of an ellipse, and for this ellipse the area is given by a is equal to pi a into b, where a is the semi-major axis and b is the semi-minor axis. So we have this expression for the area A of an ellipse. Now if we differentiate this expression, we get dA is equal to Kyle dA एक minute. Before differentiating, we should take the log on both sides. So log of this expression, taking logarithm on both sides, we get log E is equal to log pi plus log E plus log B. And now we will differentiate this. Differentiation of log A will be dA upon A is equal to, differentiation of log pi will be 0 because it is a constant, and differentiation of log small a will be dA upon A, and differentiation of log B will be dB upon B. So dA by A gives the relative error in the area of the ellipse. dA by A here gives the relative error in the measurement of semi-major axis, and dB by B gives the relative error in the in measuring semi-minor axis. So if these are the relative errors, then we can calculate the percentage error. And to find out the percentage error, what we need to do is we have to multiply this relative error by 100. So multiplying both sides of this expression by 100, we get 100 dA upon A is equal to 100 dA by A plus 100 dB by B. So this is the percentage error in the area of ellipse. This is the percentage error in the measurement of semi-major axis, and this is the percentage error in the semi-minor axis. So we are given that the percentage error introduced in measuring the major and minor axis is 1% each, so that using the value of 100 dA by A as 1% and 100 dB by B as 1% here, so we get dA by A, 100 dA by A is equal to 1% plus 1%, so total works out to be equal to 2%. So the percentage error introduced in the determination of area of an ellipse works out to be equal to 2% when an error of 1% each is introduced in the measurement of major and minor axis, right? So that is how, by using the concept of this differential, we can find out the percentage error introduced in the calculating the area of an ellipse. So there is next application of this total differential. Then we will consider the next problem, the ninth one. Ninth problem is find the possible percentage error possible percentage error in computing parallel resistance small r of three resistances R1, R2 and R3 from the formula 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So we need to use this formula for the equivalent resistance of parallel combination of three resistors if all the three resistors R1, R2 and R3 are each in error by 1.2%. So if there is an error of 1.2% each in the measurement of the values of the three resistors R1, R2 and R3, then you are asked to find out the percentage error introduced in the determination of the equivalent resistance R of the parallel combination of these three resistors. We have the expression for the equivalent resistance of the parallel combination of three resistors given by the expression 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this expression gives the equivalent resistance of the parallel combination of three resistors. Now, if we differentiate this expression, differentiating this expression, we get minus 1 upon R square dr is equal to minus 1 upon R1 square dr1 minus 1 upon R2 square dr2 minus 1 upon R3 square dr3. So if we differentiate this expression, we will get this. Now since every term contains has the negative sign, so we can cancel out the negative sign, and by rearranging this expression we can express this relation as 1 upon R into bracket 100 dr by R, multiplying both sides by 100 and minus 1, minus sign is cancelled, so we can express this like this, 1 by R. So this is 1 by R1 into bracket 100 dr1 by R1 plus 1 by R2 into bracket 100 dr2 by R2 plus 1 by R3 into bracket 100 dr3 by R3. So by rearranging this expression, we can express it like this. This expression gives, or this bracket gives the percentage error in the determination of equivalent resistance of the parallel combination of three resistors, this bracket gives the percentage error introduced in the measurement of the value of the first resistance R1. This bracket gives the percentage error introduced in the measurement of the value of resistance R2, and this bracket gives the percentage error introduced in the measurement of the value of the resistor R3. And we are given that the percentage error introduced in the measurement of the values of resistors R1, R2 and R3 are 1.2% each. So using these values of these brackets on the right hand side, we get this as 1 upon R1 into 1.2% plus 1 upon R2 into 1.2% plus 1 upon R3 into 1.2%. 1.2% can be taken common. So this is 1.2% into bracket. It is 1 by R1 plus 1 by R2 plus 1 by R3. And this bracket is nothing but 1 by R. So this is nothing but equal to 1.2% into 1 upon R. So this 1 upon R and this 1 upon R cancels. So we get the value of 100 dr by R to be equal to 1.2%. And this is nothing but the percentage error introduced in the determination of the equivalent resistance of parallel combination of three resistors R1, R2 and R3, such that all the three resistors R1, R2, R3 are having the percentage errors of 1.2% each. So the equivalent resistance also will have the percentage error of 1.2%. So that is about this equivalent resistance of percentage error introduced in the determination of equivalent resistance of parallel combination of three resistors. So let us see the next one. Next is the Poisson's formula for the flow of viscous fluid. Poisson's formula is given by phi is equal to pi p r raised to 4 upon 8 eta n, where pi is constant, as you know. P is the pressure difference between the two ends of a capillary tube. R is the radius of the capillary tube. Eta is the coefficient of viscosity of the given liquid. L is the length of the capillary tube, and this phi gives us the volume rate of flow. That is nothing but the quantity of liquid that flows through the given capillary tube in unit time, maybe in 1 second, in 1 minute, 1 hour, whatever it is. So this is the volume rate of flow. So the volume rate of flow of a fluid through a given capillary tube is given by this Poisson's formula, and this Poisson's formula is given by this expression. Now, if this expression gives the volume rate of flow of a fluid, then there are certain errors introduced in the measurement of the pressure difference, the radius of the capillary tube and the length of the capillary tube, given by the error introduced in the measurement of the pressure difference is given to be 1%. The percentage error introduced in the measurement of the radius of the capillary tube is 1.5%, and the error introduced in the measurement of the length of the capillary tube is 2%. So if these are the percentage errors introduced in the measurement of the pressure difference, the radius of the capillary tube and the length of the capillary tube, then you are asked to calculate the maximum possible relative and percentage errors in phi. Find maximum possible relative and percentage error in determining the volume rate of flow. You are asked to find out the maximum possible relative and percentage error introduced in the measurement of volume rate of flow or in the determination of volume rate of flow. So we are given this Poiseuille's formula. Phi is equal to pi p r raised to 4 upon 8 eta L. Now, if we take the natural log on both sides, we can express this relation as ln of phi is equal to ln of pi plus ln of p plus 4 times ln of r minus ln of 8 minus ln of eta minus ln of L. So, by taking the natural log on both sides, we get this expression. And now, if we differentiate this expression, we get differentiating both sides of this expression, we will get the differentiation of ln of phi is dv by v. Yes, yes. It is dv by v is equal to, since pi is constant, ln pi is again a constant, its differentiation will be 0. Ln p, differentiation of ln p will be dp by p plus 4 times differentiation of ln of r will be dr by r. Ln of 8 is a constant, so its differentiation is 0. Eta is constant for the given liquid, so its differentiation again will be 0, and it is minus differentiation of ln of L will be dl by L. So we get dv by v is equal to dp by p plus 4 times dr by r minus dl by L. But this error introduced in the measurement of the length of the capillary tube may be either positive or it may be negative. We do not know. So, since we are asked to calculate the maximum possible relative and percentage error, we have to consider only the positive error in the measurement of length of the capillary tube, so that we can write the expression for the relative error in the measurement of volume rate of flow as dv by v is equal to dp by p plus 4 times dr by r plus dl by L. Remember why this plus sign is taken. Since we are asked to find out the maximum possible relative error, we have to consider the positive error in the measurement of the length of the capillary tube. So, it is taken to be positive here. So, by multiplying by 100 on both sides of this expression, we will get before multiplying by 100, we can first find out the relative error in the measurement of volume rate of flow. Since the percentage error in the measurement of the pressure difference is 1%, the relative error dp by p will be equal to 1 upon 100, so it is 0.01. The percentage error in the measurement of radius of the capillary tube is 1.5%, so that the relative error in the measurement of radius of the capillary tube will be 0.015, and the relative error, the percentage error in the measurement of the length of the capillary tube, since is given to be 2%, the relative error in the length of the capillary tube, that is dl by L, will be equal to 0.02. So using these values of dp by p, dr by r and dl by L in this expression, we get the relative error in the measurement of volume rate of flow to be equal to 0.01 plus 4 times 0.015 plus 0.02. So this works out to be. So this is 0.06, 0.07, 0.09. So that it works out to be equal to 0.09. So the relative error in the measurement of volume rate of flow works out to be equal to 0.09. And to find out the percentage error, we have to multiply it by 100. So 100 dV by P will be equal to 100 into 0.09. So this works out to be equal to 9%. So this is the percentage error in the measurement of volume rate of flow, and this is the relative error. And this is percentage error. So that is how we can use the concept of this differential or total differential in order to find out the approximate value of certain functions, or we can find out the percentage and relative errors introduced in the measurement of certain physical parameters. So with that, we'll stop it here for today, and next then we'll continue in the next video.